Okay, so now I'm working on the open system, okay? Open system. So open system, it means that whatever the species that can interact with air, it will do the interaction, okay? So this is how I did it. I said this is the open system, okay? And this open system is prepared by adding 10 to 3 mass more of Na2CO3 and 10 to minus 3 more of HCl, right? And then I say, well, in the air, there is already have a CO2 in the air, and that PCO2 is 10 to minus 3.39. I use bar, right? Okay, bar. So with this, I said that let's find out the pH. The first one is find the pH, and second one is that I'm asking you that if CO2 go into the solution or leave the solution, okay? CO2 in or out of solution, how much? Okay, so that is the question I set up, and I ask you to solve it. To solve this question, you always go back to the procedure I told you. The first one is to list the unknowns you have in your system. So unknowns. That is the concentration. I didn't know that. I didn't know, right? So unknown, I asked you to write in the way, each pair, right? So you write water first. So you have H plus and OH first. We don't know the pH, so I need to know it, right? And then you add CO3 in, right? You add sodium carbonate in. So there's a acid and base pair for carbonate, bicarbonate, all those things. So you have H2CO3, HCO3 minus, and CO3 2 minus. After that, you have what? Chloride there and sodium, right? This is just the ion will be inside. So actually, if you take a look, you have 1, 2, 3, 4, 5, 6. Yeah, 7 unknowns, and then you need 7 equations to solve it. To solve it, 7 equations, you have equilibrium equation. Equilibrium, you have Kw. I'm not going to write it now, okay? You all know what is Kw and K1 and K2. So you have 3 equations. Ready? You have 3 equations. And then you have mass balance equation, right? The mass balance, you have total sodium. And since sodium you add in is sodium bicarbonate, so 1 more sodium bicarbonate will be 2 more sodium. So sodium will be 2 times 10 to minus 3. Very important, okay? This sodium, there are 2 here, right? So you add 10 to minus 3 more, this 2 will make it 2 times 10 to minus 3. And then you have chloride. Chloride only 10 to minus 3 is from HCl. So we have 2 equations here, and we used to have 1 equation called total CO3. Total CO3 always the summation of these 3 species, right, together. This equation is okay. Total CO3 is like this, but the reason is that we don't know how much, we don't know the value. I know I added in 10 to minus 3 initially, right? I added in 10 to minus 3 initially, but because it's open system, so it means that this 10 to minus 3 could be increased if CO2 getting in, or decrease. So this equation looks like the good equation. It's totally valid, okay? But you don't know the value. That is why I don't know the value, okay? So let's make it, this equation is not going to work, okay? And the other one, of course, you can do charge balance. Charge balance, we have sodium plus H plus equal to OH minus chloride right? So it means that I have 7 unknown, but I only have 1, 2, 3, 4, 5, 6 equation. So 7 unknown, but only 6 equation. I need one more equation to find the result, and that is that pK, the Henry's constant coming in. Okay, so in here I'm going to add the other one in. So Henry's constant, call me like KH equal to what? What is the KH value I told you earlier? 29.9. Okay. 29, just 29. Okay. Atmosphere divided by mole per liter, right? Like this. Okay. And we can find you bar. Okay. So maybe let's do this for right now. Okay. I'm going to call it bar, so it will be easier. Okay. Because I give you bar here, isn't it? Yeah, I give you bar here. Okay. So this value, the KH, you can find it from where? From the internet, you can find it. But you need to look at that unit to make sure that unit is the unit you like. Okay. Then with that, you say, okay, this KH equal to what? PCO2 and H2CO3, right? And this PCO2 already how much? 10.3.39, right? So it means that from this equation, the H2CO3 already the known number. Okay. With that, you need to go through it, but you know that I have 7 equations and 7 unknown. I can solve it. After you solve it, you find a pH. This one you cannot do it by graphic methods. Probably not that easy. Can we do it? Maybe we can do it. I can try it. Not that easy. Okay? So this is how it works, okay? So you go to the Excel, you know this number, you know this number, and you know you know what? This based on KW, right? And this two can based on K1, K2, but there's no total CO3 now, right? But you already know H2CO3, you know everything, then you can solve it, okay? Probably some of you will ask me, but probably none of you will ask me, can we do total H? Find the dominant species here. In this one, you don't need to do it. The reason is that you always put H2CO3 in the reference. Do you know why? If you don't put H2CO3 in the reference, it will sit on the right? Then when we do the total H in, we will ask, did you add H2CO3 into the system? Yes, because you open. So there's the possibility CO2 getting in. Then you are doomed because you say, I need to know H2CO3 total H in, but there's no way you can know it. That's why in this one, I don't do dominant species and I don't do total H equation. If I want to write total H equation, I definitely will put H2CO3 in the reference. Okay? But when you put it, the equation will look exactly this one. Okay? Method to solve this one. Instead of Excel. In Excel, you can do it no problem. Now I'm going to use graphic method to solve this one. So how do we do it? The first one is that you want to draw log C pH diagram, right? So first thing is that you know that H2CO3 always a constant. Based on this one, H2CO3 will be a constant, right? It doesn't affect it by pH. So I'm going to write KH equal to okay, give me the number. How much is it? -4.85. 0.85?
Yes.
Okay, so that's the first line I can draw, right? Now you need to draw HCO3 minus. How do you draw it? Let's do that right now. We know that Ka1 equal to right? So that's from Ka1. So I can move it around. I will put HCO3 minus on one side and move everything to the other side. Okay, so I just moved it around, and then I take log because I need to know the log of bicarbonate, right? So I just take log. So you take log, that will be, I'm going to write down like this. You have no problem with that, right? Take log. You just take log and move that exponential down to the bottom, and then you have plus log H2CO3 and minus log H plus, right? And this is 6.35, and log H2CO3 is minus 4.85. And this minus log H plus is pH, so I just plus pH. So you got this number, given the number, add it together, so it will be the 2 minus 11.2. See, you got another line, right? And then you do the same thing for CO3 2 minus, okay? CO3 2 minus, I am going to use Ka2. Ka2 equal to 3, right? Okay. Again, I'm going to move it around, so okay. And you take log again. Right? So you add it in, you plug in this one, so that would be minus 21.53 plus 2 pH. Okay. So we got everything for this, and that equation here, where is the equation? Here, the charge balance look like we all charge sodium just 1,9 there. Chloride is the 1,9 there, right? So everything already there. Then let's draw it all together and see how it works, okay? Actually, this one I can do it again. Let's do it. If I plug in the number, this is 2 times 10 to minus 3, right? And this is, no, this one. 10 to minus 3. So the new equation will be just 10 to minus 3 plus h plus equal to what? That is the equation I want to find my pH. Right? So now let's do it. Okay? Okay. So what I'm going to do, let's draw it. I can do it from like pH 2. 2 is okay. And this one I'm going to do from minus 1, minus 2, minus 3, minus 4. Okay, so the first line will be 7, 7 is this point, right? I'm going to draw which one? The H plus is from 2 like this. I'm going to do it like this. Oops. Okay, it's okay, it's in. So that is H plus, right? And I need to do OH or OH minus. That will be here, I guess. Oops. Oh, come on. I can do better than that. Okay. I think I can move it a little bit. Okay. And then what else I need to do? The first one is H2CO3, right? How much is it? 4.8? 4.85. So this is 4.5, 4.75, 4.85 maybe here. So I can just draw a line like this. Okay? So this is H plus, OH minus, and H2CO3, right? And the other one is, which one? HCO3 minus is minus 11.2 plus pH, right? So you think about that. If I add pH 2 in, that would be, at pH 2, it would be how much? Minus 0.92, right? So pH 2 will be minus 0.92. Let me write that equation here. Log HCO3 minus is minus 11.2 plus pH, right? So you can add 2 in. Add 2 in will be minus 9.2. 9.25 minus 9.2 is here. So that's the first point. And then I can add another point like pH 5. If I add pH 5, that will be minus 6.2, right? So pH 5 here This is pH 5 and minus 6.2 will be here. So that point may be here. Okay. So I'm going to put that point in there. 6.25, 6.2. Okay. And I can draw that curve here like this. Okay, if I can do it, okay. Okay. Okay, you got okay with that? So this one is HCO3 minus, right? And then I have another one is minus 21.53 plus 2 pH, okay? Log minus 21.53. So if I give it 4, for example, wait, do it? No, I'm going to do 5 right now. 5. I'm going to do 6. I'm going to plug in 6. If it is 6, pH 6, how much would that be? Minus 21.53 plus 12. Can you give me the number? 9.53, is that right? Okay. So when it's 6, it's 9.53. This is 9.5, 9.53. That point is around here. Okay. And then I'm going to give it 10. When it's 10, I'm going 9 will be enough. Okay. If I give it 9, it's 18, so it's minus 3.53, right? So 9 is this line, 9 is here, and how much I say? 3.53, right? 3.3, 9 is here, 3.53 is here. So that curve will look like that long line will look like this. These 2 points. Okay. Not very accurate. You got okay with this one? CO3 2 minus. Okay. Now, what is my left hand side? Let me copy it here. Left hand side is 10 to minus 3 plus H plus, right? 10 to minus 3 actually just this line though. Okay? And H plus plus 10 to minus 3. So the left hand side equation will look like just like this. Okay? Is that okay? And the right hand side will be OH, HCO3, and 2 times of CO3 2 minus. Look like OH never be the one on the top, isn't it? OH is here, so OH very low. But HCO3 and 2 times of CO3 2 minus. I have CO3 2 minus here, right? How do you do it 2 times? Do you know how to do it 2 times? Just one line shift 0.3. That will be 2 times. But anyway, look like it will follow this line here and then go to this one. So the point will be here. Okay. Even though this one is called CO3 2 minus, right? And 2 times will let it shift this way, 0.3 point. But HCO3 minus will be dominant at this portion, right? So this one already quite low, even though it shift a little bit, it's okay. So the way I'm going to draw the right hand side, I'm going to draw like this. This shift 2.3 a little bit, right? And then go like this, go like this, go like this. And then we go to this one, and then going down, okay? So this will be the pH we have, actually. This is the point. That point will be like how much? About 8.2 or 8.3. You guys can check it with Excel, okay? So, you know pH now, right? The solution will be 8.2. And then you add that pH back to your equation. You will find the concentration for each one, right? And you add it up together, you will know the total CO3. And how much we added initially, 10 to minus 3. So if you compare, you know that if the total CO3 now is higher than 10 to minus 3, it means that CO2 getting in. If less, then it means CO2 going up.